Now, so this is question number 6 out of 3.8, and we're supposed to use implicit differentiation to find dy dx without first solving for y. Okay, so let's go ahead and get started. So step number 1, I'm going to go ahead and write out my problem. X plus y to the third equals x to the fifth and y to the fifth. Okay, so y'all, I'm going to start on the left side here. I'm going to take the derivative of this. So in order for me to take the derivative of this piece here, that 3 is going to come down. We're going to have x plus y. Remember, we're going to reduce it to the power of 2. Then we have to take the derivative of what's inside. So the derivative of an x is a 1. The derivative of a y is a dy dx, okay? Equals. Now, I'm going to do this part. Y'all, I'm going to use my product rule, okay? So if I'm taking the derivative of this, it says first I got to take the derivative of the first function. So I'm just going to kind of write it over here. That's going to be a 5x to the fourth times the second function plus the derivative of the second function. That's going to be a 5y to the fourth and a dy dx times the first function, okay? So look, I'm just going to rewrite what I have already. I'm going to write 3x plus y squared, 1 plus dy dx equals, let's see, 5x to the fourth, y to the fifth, plus 5, y to the fifth. I'm going to go ahead and write the x to the fifth, or y to the fourth, I'm sorry. Let's see, here we go. Yeah, it was a y to the fourth, x to the fifth, and then a dy dx, okay? Now, my next step, y'all, I'm going to go ahead and multiply this times both those pieces. So we're going to have 3x plus y squared times 1 is the same thing. And then 3x plus y squared with the dy dx equals 5x to the fourth, y to the fifth, plus 5 y to the fourth, x to the fifth, and my dy dx, okay? Now, what I want to do now, y'all, is I want to get my dy dx's on the same side. So I'm going to leave this guy here, and I'm going to bring this one over that way, okay? So let me do that on the next slide. I'm going to put 3x plus y squared dy dx, okay? 3x plus y all squared dy dx, okay? When I move this guy over, it's going to become negative. So minus 5y to the fourth, x to the fifth. Minus 5y to the fourth, x to the fifth, and a dy dx equals, okay? I'm going to leave that guy alone. 5x to the fourth, y to the fifth. 5x to the fourth, y to the fifth. And let me see. I'm going to bring this guy over the other way. So it's going to become a negative 3x plus y all squared. Okay? All right. Next step, y'all. Let's factor out the dy dx. Okay. 3x plus y squared minus 5y to the fourth, x to the fifth equals 5x to the fourth, y to the fifth minus 3x plus y squared, okay? All right, last step, let's get rid of this guy, okay, by dividing it. Okay, minus 5y to the fourth, x to the fifth. Okay, so now my final answer for dy dx is 5x to the fourth, y to the fifth, minus 3x plus y all squared, okay, over a 3x plus y all squared, minus 5y to the fourth, x to the fifth, okay? So here's my answer for my dy dx, okay? So that's exactly what I would put right here. Now, y'all, I'm going to just give you a heads up. When you're doing this step here, just be really cautious of your powers and where they go, because typically, like I said, when I did this class last semester, that's where people made the mistake, okay? Now, there's a second part to the question. Let's see. Find the slope and y-intercept of the tangent line in the form y equals mx plus b to the curve at, oh, do we have the point? So, I don't know if I have the point here, y'all. Let me check something, because who sent me this picture, I don't think I have the point. Let me double check. I don't see it here. Yeah, so I'm missing the point, y'all, I'm missing the point for the second piece. Oops, let me get this going again. I'm missing the point for the second piece right here, okay? So when you sent me the screenshot, I'm missing that point, okay? So I don't know what the point is. I want to say, though, is the point 1, 1? I think it was 1, 1. Let me try. Let's try doing it that way. Let's try doing it at 1, 1. I'm not even sure if that's the point of what they gave us, but let's try 1, 1, okay? Because I think when we did the problem like this in class the other day, that was the point that we had. 5x to the fourth, y to the fifth? Or maybe it wasn't, I don't know. Minus 3x plus y squared. Okay, over 3x plus y squared. Minus, and it wasn't 1, 1. And now I think about it, it wasn't 1, 1. 5y to the fourth, x to the fifth. Okay, so yeah, it wasn't the point 1, 1. So y'all, who sent me this problem, I need the point that you have right here. So if you want to send me that point, y'all, then what I can do is I can make a second video and I can work from this point forward, okay? Because we're missing that point that we have right there. But this is how we would do the first piece, okay? And then the second piece